Have you ever stopped and wondered what happens when things just seem to disappear? When something burns up or dissolves or rusts away, where does it actually go? Well, today we're diving into a fundamental law of the universe that has the answer.
Think about a campfire for a second. You start with a big, heavy log, right? And after a few hours of those crackling flames, what are you left with? Just a tiny, light little pile of ash. It really feels like almost the entire log just vanished into thin air. But did it? Where did all that stuff actually go?
The answer to that whole campfire mystery is hiding in one of the most important rules in all of science. It's a principle that's at work in every single chemical reaction, from a star burning billions of miles away to the cells firing inside your own body right now.
And here it is. It's called the law of conservation of mass. Now I know, that sounds pretty technical, but the idea behind it is actually super simple. It just says that if you have a closed system, think of it like a perfectly sealed box where nothing can get in or out. The total amount of stuff, the mass, inside that box will never ever change, no matter what happens inside.
Here's a much simpler way to put it, and this is really the heart of the idea. You can't just create matter out of thin air, and you can't make it vanish into nothing. All you can do is change its form. It just rearranges itself.
So let's go back to our campfire. That log didn't disappear at all. It just went through a chemical reaction, burning, and it transformed. If you could somehow trap and weigh everything that was created, all the ash, all the smoke, and all the invisible gases like carbon dioxide and water vapor, you'd find that their total mass is exactly the same as the original log plus the oxygen it used from the air. See? Nothing was lost.
Of course, science being science, it loves to prove things with numbers. And this law has this beautifully simple little equation at its core that shows this perfect balance. And there it is. The mass of the reactants equals the mass of the products. Just think of it like a perfectly balanced kitchen scale. Whatever ingredients you put on one side have to weigh the exact same amount as what you get out on the other side.
So what are reactants in products? It's really straightforward. Reactants are just the ingredients you start with. The products, that's the new stuff you end up with after the reaction is done. Simple as that. Starting materials and final results.
Okay, let's look at a classic example. Making water. Hydrogen and oxygen are your reactants, your ingredients. Now, if you combine exactly 2 grams of hydrogen with 16 grams of oxygen, you will get exactly 18 grams of water. That's your product. 2 plus 16 equals 18. The math is perfect. The mass is perfectly conserved.
But this isn't just something that happens in a lab coat with beakers. This fundamental rule is happening all around us, all the time. Let's look at a couple more examples you'll definitely recognize.
How about an old iron nail you find outside? Over time, it gets rusty, right? Well, that's another chemical reaction. The iron nail is one of your reactants. It grabs another reactant, oxygen, straight from the air. And together, they transform into a totally new substance, a product we call iron oxide or just rust.
But here's the crazy part, the bit that might surprise you. If you were to put that rusty nail on a scale, you'd find it's actually heavier than the original shiny nail. Why? Because the iron didn't just decay, it added something. The rust now contains the mass of the original iron plus the mass of all those oxygen atoms it grabbed from the air.
And once you start looking for it, you see this law everywhere. When you eat an apple, your body digests it, breaking it down into energy and waste, but the total mass stays the same. When you bake a cake, the final cake plus the steam that evaporated equals the mass of all your batter. An ice cube melting into water, same exact mass. A car burning gasoline, it's just turning it into exhaust gases, but the mass is constant. It's everywhere.
So, okay, it's a really neat scientific rule, but what's the bigger picture here? Why is it so important to understand this?
Well, here's what it all boils down to. Nothing in our universe is ever truly lost. Matter can change from a solid to a liquid to a gas. It can be rearranged in millions of different ways, but its mass is constant. The amount of stuff you start with is always the amount of stuff you end with. And that simple, powerful idea, it's the absolute bedrock of all modern chemistry.
And that kind of leaves us with one last big thought to chew on. If matter is never created or destroyed, if it only changes form, then what does that really mean for all the things we use and then throw away? Where exactly is away? This law of science really forces us to think about cycles, about transformations, and about the fact that everything we get rid of has to go somewhere, in some form.